Okay, now something totally different. It's graphing inequalities. So we'll start off, we'll take some quick notes. It's really only a couple key points to graphing inequalities to keep in mind. So I'm going to put up just some basic functions. So y less than x, y greater than x, y less than or equal to x, or y greater than or equal to x. Okay. And if you have graph paper, this would be a really great day to use it. If not, that's okay, because hopefully you've graphed enough points, you have the basic idea of what a grid should look like. So if we say y equals x, if this was just a line, if we just said for a moment, don't write this down, if we just said y equals x, you know, it would look like that. Only it would go through the origin more precisely, okay? But when we do inequalities, it's a little bit different. So there's a couple things we need to keep in mind. It's still the same basic, like the line's gonna look the same. It's gonna go the same direction. But because it's only less than, it doesn't actually include the line itself. So anytime you see less than or greater than, instead of putting a solid line, we indicate that with a dashed line, not a dotted line, a dashed line, just like that. Okay, so it shows that this is still the key point here, but it doesn't actually include any values on that line. Okay, but what it does include, since we're saying y is less than x, this actually includes every point underneath the line. So after we graph this, if you have a highlighter, you can do something like that there. If you don't have a highlighter, if you just have like a different color, I've seen people and they go like that, just mark it off that way. Or you could, and this is, I've kind of been liking this idea more and more. The more I see it, it's just drawing a couple arrows pointing down to show that this includes every point underneath the line. Okay? If we have y greater than x, it's very similar. The line is exactly the same. Only since it's greater than, instead of shading below the line, you would shade everything above the line. Okay? And then we come to our other set, less than or equal to, greater than or equal to, is very similar. The only difference, you used your smartness, you probably figured it out already. Instead of drawing a dashed line, since it can also equal x, then we're going to go back to making a solid line. Okay? But we still need to shade it, so it's less than. So just like before, it's everything beneath the line. Okay? And then y greater than or equal to x, still this blue line. Greater than or equal to, so it's going to be a solid line, and then we're going to shade everything above. Okay? So all of your graphs are going to have these characteristics. It's either going to be dashed or solid, and you're either going to shade below the line or above the line. Okay? It's one of the, or a couple of things we're going to test for, but that works better if we have actual numbers. So I'm going to come to look at my examples. So it's going to give it to you in standard form. If you want to graph this, I mean, technically you could graph from standard form, but generally, no. Let's say all the time, because we have some negatives that's going to flip the sign. So we want to change everything back to slope-intercept form. So I want y all by itself every time. So I'm going to move this 5x first. So minus 5x from both sides. So that's going to give me negative 4y greater than, because I haven't multiplied or divided yet, so the sign stays the same. I'm going to put my x first, just so it'll look like slope-intercept form a little bit better, minus 12. Okay, when we divide here, this is important, we don't want to forget this. We divide the left side by 4, and then we divide everything on the right side by negative 4. Okay, so this is going to cancel out. So we're going to be left with y. And then since we divided by a negative, the sign's going to flip. So instead of greater than, it's going to be less than. Negative 5 divided by negative 4 is just 5/4 x. Remember, negative divided by negative is positive. And then 12 divided by negative 4 is positive 3. Okay? And this isn't great. I wish. Slide all this up. Get rid of that. Okay. Hold that looks a little better. Okay, so now we want to plot this. So we start off at positive 3. Right? Messes up there. No, okay. And then we can just count from there. So since it's positive 5, we'd go up 5 and to the right 4. But since that's not going to fit, I can go the opposite way. So I'm going to go down 5, 1, 2, 3, 4, 5, and left 4. That gives me my second point. Let's make sure it's actually blue. I wish it gave me the color one. Okay, since it's just less than, I know I'm going to put a dashed line. So best I can, put a dashed line here. Okay, since it is, oh my goodness. So it's not all in the way. Should have organized this a little better. Okay, since it's less than, I know I want to shade below the line. So we get on my highlighter, so you can see it that way. So everything below the line. So if I pick anything in this yellow here, and I can even, I want to get fancy with my color, it goes all the way right up to the line, but not including it. If I pick any point in that yellow, it should make my inequality true. So the point we check, I can check any of these, but a point you're going to see as a good checkpoint is 0, 0, just because it makes the math really easy to do. So if I want to say, is this point, is that really part of the solution set? So if I replace x and y in my equation with 0, so I have 0 is less than, what do I have? Sorry, space it out. 5/4 times 0 plus 3. So all this cancels out. So I'm left with just 0 is less than 3. Is that true? Is 0 less than 3? Yes, it is, which means it has to be included in my graph. Okay? So we don't always need this to be true. It just tells us and makes sure that it matches what it's like. If we had said, if this was a different equation, y was greater than 5/4 and we had shaded above the line, when we checked this, we should have ended up with a false statement. Okay? So we can check 0, 0, even if we don't think it's going to be part of the answer, just to see if we shaded the right side or the correct side. Hopefully that makes sense. I know it's a little confusing hearing it all out. When you practice it, I promise you it'll make more sense. Okay, so let's try the other one. 9x minus 5y less than or equal to negative 20. So same thing, we want to get x by itself. I'm going to write it a little bit smaller this time, so hopefully it'll fit. So minus 9x to both sides. So that is negative 5y less than or equal to negative 9x minus 20. So same as before, I want to get y by itself, so I'm going to divide everything by negative 5. Okay, this is going to cancel. So y is, and then again it's by a negative number, so we're going to flip this. This is going to become greater than or equal to. Negative 9 divided by negative 5 is positive 9 over 5 x. And then negative 20 minus 5 is positive 4. Yeah, that'll fit. Okay. So if there's my inequality. I know my y-intercept is positive 4, so I can start with a point there. And then again, since the slope is positive, it would go up 9 over 5, but I can't do that because there's not enough room, so I'm going to count down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, back 5, 3, 4, 5, there we go. So this time it's greater than or equal to, so I'm going to put a solid line. And this one is greater than. So I'm going to shade above the line. So everything above the line I'm going to shade. There it is, perfect. Okay. And then I can check to see, is 0, 0 a point? So this time, so you see now 0, 0 is not in the shaded area. So when I test this, it should not come out to be true. So let's see. So if I say 0 is greater than or equal to 9/5 of 0 plus 4. So this again will cancel out. So is 0 greater than or equal to 4? And the answer is no. So since it's not true, it should not be an answer. And that's what we got. We said it's everything above the line, which does not include that number. This is a good answer. Okay. So the whole reason we do this is just to make sure we shaded the right side of the line. So we pick one point, and assuming the line didn't go through 0, 0, okay, so if it's proportional, you're going to have to pick some other point. But most of the time, you can use 0, 0. And that way, it'll tell you, it'll make sure that you shaded the correct way. As far as knowing if you put the right kind of line, dashed or solid, you can tell that just from looking at the problem. Because it can't change from here. It'll tell you greater than, it'll tell you less than or equal to right from the very beginning. There's no reason to miss that one. Okay? The only other questions you see on there is asking for x and y intercepts. That's nothing new. You've done that before. Set x or y equal to 0 and solve for the rest. And that should get you through today. If not, send me your questions. Okay, bye.